Hello, everyone, and welcome to TMM6666, Drug Discovery and Development. My name is Josh, the course coordinator. We are lucky to have a panel of experts here today to explore the drug colchicine. We'll start off with our first speaker, Tracy.
First, a bit about gout, the disease that colchicine targets. Gout is a common and severe form of arthritis caused by uric acid buildup in the body. It results in pain, swelling, and redness in the joints, typically forming in the big toe or a lower limb joint. Gout prevalence has been on the rise globally and is now the most common form of inflammatory arthritis in the US, affecting about 3.9% of the entire adult population. So when uric acid builds up in the body, it's mostly found in the more soluble anion form urate. Uric acid is produced when we break down purines from our diet or nucleic acids in dying cells. Normally, dissolved urate passes through the kidneys and into the urine. However, buildup can occur due to a purine-rich diet or when the kidneys excrete too little of it. High levels of urate in the blood form these needle-like monosodium urate or MSU crystals in the joints. However, MSU crystals don't always trigger inflammation. In stage 1 of this diagram, the crystals are deposited, but there is no gout attack. To trigger inflammation, activation of innate immunity must occur. This is a process involving serum proteins, neutrophil recruitment, which then produce ROS, proteolytic enzymes, lots of inflammatory cytokines, all summarized in stage 2, and you don't have to memorize any details. The main point is that innate immunity activation, not the mere presence of these crystals, is what triggers inflammatory gout attacks. Next, we have a video about colchicine's mechanism of action.
Colchicine disrupts microtubule formation by binding to both alpha and beta tubulin to prevent polymerization. Disturbing such a vital facilitator of transport in the cell can have various detrimental side effects, but at low concentrations this drug can help to counteract the inflammation characteristic of an acute gout attack. This nonspecific mechanism of action creates many different pathways that contribute to the same therapeutic effect. One such pathway involves the reduction of E-selectin and L-selectin expression on the cell surface of endothelial cells and neutrophils respectively. Microtubule downregulation interferes with the trafficking of these selectin glycoproteins to the cell surface, which are normally responsible for the adhesion of neutrophils to endothelial cells. Neutrophils are a key player in the body's innate immune response to a buildup of monosodium urate crystals, the defining feature of gout. So when their adhesion to inflamed tissues is diminished, so is the inflammation.
Now we will hear from Paul about clinical trial results.
Clinical trials for colchicine show promise but also highlight areas for improvement. A Cochrane review last updated in 2021 identified 4 trials on colchicine for gout. In a 1987 trial, 43 patients, all receiving a high dose of colchicine, said that it significantly relieved pain. 2/3 of these patients had over 50% pain relief compared to the 1/3 for the placebo. All experienced side effects like nausea and diarrhea within 36 hours. A 2010 trial with 184 participants comparing a high to a low dose of colchicine found that low dose was both well effective and well tolerated, but the review raised concerns about the methodology. Due to these side effects, experts often recommend other NSAIDs. Additionally, colchicine might prevent cardiovascular events, but data limitations restrict its broader application. In conclusion, colchicine shows promise, but we need more robust trials.
Now it's time for our Q&A period. Oh, I see that Mia has a question.
Yes. Could you explain how colchicine was discovered?
Colchicine's origins can be traced back to a millennium ago, where people consumed the colchicine-containing plant Colchicium autumnale. Colchicine was only first isolated in the early 1800s by P.S. Pelletier and J.B. Caventou, and was purified and named officially as colchicine in 1833 by P.L. Giger. Its mechanism of action was discovered in 1945 by Michael Dewar when he saw that colchicine was able to bind to microtubules thanks to its 2 7-membered rings. As to when colchicine was formally approved for use, the FDA did so in 2009, where it was marketed under the name Colchris. Hope that helps.
Thank you.
I have a question. Is there any way that colchicine can be improved?
Yes, the clinical trial phase could have seen many improvements. There were concerns of reporting biases in pain scores and unclear randomization of participants, leading to low-quality data.
So how could they increase the trial quality?
They could assign patients to treatment and control groups in a more randomized manner, increase sample size, and also simply perform more trials.
What other information could higher quality trials provide, though?
Given a better understanding of colchicine's mechanisms, we can improve its efficacy, reduce side effects, and even discover new treatments for gout, like combination therapies.
In short, colchicine treats the symptoms of gout by inhibiting the immune response to deposited urate crystals. Some clinical evidence shows that the drug is effective, but the number of good clinical trials is limited. Thus, more work can give a clear picture and help address the increasing global burden of gout.